Hello everyone, welcome to Daily Ka Funda series. This is Sanjay Rathi. Today we are going to discuss Shunt Voltage Regulator, that is by using BJT. Okay, and that is very important topic for a GATE exam, engineering services exam and other competitive exams, and that is your journey to GATE, guys. Stay tuned with us, subscribe the channel. Now that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks in ESE, AR 16 in ESE 2005, AIR 21 in ESE 2008. And I have trained more than 1 lakh students for these competitive exam, guys. Now this is my Telegram channel, that is Electronics by Sanjay Rathi. You can join for notification or just to improve your concept. If you have any doubts, then you can post here. If you have any suggestion, then give me suggestion on this channel, that is Electronics by Sanjay Rathi. Then guys, what is the shunt voltage regulator? So I am going to discuss shunt voltage regulator, that is the standard circuit. For that I am going to redraw the diagram and I will explain each and everything about this, guys. Then first of all, that is a shunt voltage regulator. Shunt means what is the position of the transistor with respect to RL. Now watch this. Here we are having one series resistor RS. Right. Now here we are having one Zener diode. This is the Zener diode. Now we are having one transistor here. This is connected here and that is the output. Here we are connecting the RL. Here we are connecting RL. When we are comparing with the RL, transistor is connected in parallel to RL, right? And that's why it is called what? Shunt voltage regulator. Here we are taking V0. Now, here we are giving Vi. We are having variation in Vi, that is called line variation. It may be vary from 20 to 30 volt or 30 to 40 volt and so on. And there is a variation in RL also. This is also variable, that is called load variation. Now, what is the function of this circuit? For full range of Vi and for full range of RL, right, from V minimum to V maximum and RL from V minimum to V maximum, diode should be in what? Breakdown region, and BJT should be in active region. So this is in active region and that's why this voltage is fixed. From this point to this point, this is fixed VBE. This is in breakdown region, that's why it is also fixed VZ. Now from this point to this point, we are having the VC, and from this point to this point, we are having V0. And therefore, what is the regulated voltage? V0 is equal to VZ plus VBE. Now VZ is constant, VBE is constant, and that's what is called VZ, and VBE is called what? Regulated voltage. Okay, so that is the regulated voltage. Now here, what is the next question? Next question will be, what is the power dissipation across this transistor? So what is the VCE? VCE is nothing but V0, that is the VZ plus VB. Now watch this. This is the current I. That current is divided into three parts. One is what? IZ, one is what? IC, and one is what? IB. IL means that current I is divided into three parts: IZ, IC, and what? IL. This IZ is nothing but IB, right? This is IB. Now we can write I is equal to, first formula, Vi minus V0. This is Vi, that is V0, Vi minus V0 upon RS. First important formula. Then second one, second for this diagram is, this I is divided into three parts: IZ plus IC plus IL. I is divided into IZ plus IC plus IL. Now what is the IZ? IZ is nothing but IB. IZ is nothing but IB, and that's why what is the IC is equal to beta times of IB, or you can write beta times of IZ. Right, so that is the equation number 1. This is the equation number 2. That is the equation number 3. Now, what is the IL? IL is the nothing but V0 upon RL. Right? Now, what is asked in the question? What is the power dissipation across the Zener diode and what is the power dissipation across the transistor? Then, watch this. Power dissipation across Zener diode is given by PZ is equal to VZ into IZ. And power dissipation across the transistor is given by VCE into IC. VCE into IC. Now, normally we have to find what maximum power dissipation. When we are going to get the maximum power dissipation, to when IZ is maximum because VZ is fixed, and when IC is maximum because VCE is fixed, VCE is nothing but VZ plus VB, we have to find the IZ maximum and IC maximum. What is the IZ and IC? To watch this, in this diagram, in this equation, we can write I is equal, what is the IZ plus IC? IZ plus IC is equal to I minus IL. I minus IL. And when we are going to get the IZ, what is the IC? Beta times of IZ. So you can write here IZ plus beta times of IZ is equal to I minus IL. Then from this you can write a very important equation. IZ is equal to IZ 1 plus beta, you can take IZ common, is equal to I minus IL. Then when this quantity will be maximum, IZ maximum means this should be maximum, this should be minimum, divided by 1 plus beta. This should be maximum and that should be minimum divided by what? 1 plus beta. And when we are going to get the I maximum means Vi maximum minus V0 upon Rs. So this I will be maximum because V0 is constant, Rs is constant when Vi is maximum. So always remember I maximum you have to find Vi max minus V0 upon Rs. Now, what is the IL minimum? Now, there are two cases, guys. Always remember, if this RL is fixed, we can't remove it. Then always remember, RL will vary from RL minimum to RL maximum. If it is fixed, RL is fixed, then IL minimum is equal to, if RL is non-removable, we can't remove it, then IL minimum is given by V0 divided by RL maximum. Always remember. For example, if the RL vary from 100 ohm to 1 kilo ohm, you have to choose what? 1 kilo ohm here, right? So RL maximum. Or if RL is removable, suppose you can remove it, removable, then always remember you can make RL infinite, make it open circuit, and therefore IL minimum will become 0. This is called worst condition. Minimum will become 0. So when IL minimum is 0, then guys, this formula, you have to find the I maximum from that. You can put IL minimum and then 1 plus beta, you will get the IZ maximum. From IZ maximum, you can find the maximum power dissipation. From IZ maximum means what? IB maximum, because IZ is equal to IB. Therefore, IB maximum will become IZ maximum. And then guys, what is the IC? IC is equal to beta times of IB. So what is the IC maximum? Beta times of IB maximum. Now VCE is fixed, IC maximum is beta times of IB maximum. So what is the maximum power dissipation across the transistor? VCE beta times of IB maximum or IZ maximum. So in this way, you will get the worst condition, guys. So always remember, there will be two cases where the RL is fixed or means not removable, then you have to use the RL maximum here. Or if it is removable, means we can remove it, then guys, worst condition will become RL is infinity, IL minimum is 0. Use this formula for shunt voltage regulator and try to solve this question, guys. This is the question where we are having a 20 ohms RS resistor. There is a Zener diode, VB 10 volt output voltage, and V vary from 20 to 30 volt. So what is the question here, guys? Question is, the transistor shunt regulator shown in the figure has a regulated output voltage of 10 volt. When the input varies from 20 to 30 volt, the relevant parameters for the Zener diode and the transistor are Vz is equal to 9.5 volt, Vb is 0.5 volt, beta is 99. Neglect the current through Rb, then the maximum power dissipated in the Zener diode and the transistor are. Okay. And now guys, one Rb is connected here. RB is connected here, but simply in this particular question you have to simply remove the RB, because what is the current through the RB? Negligible. Okay. Now you have to solve this question. So what is the name of this series, guys? Journey to Gate, how to build concept, daily ka funda plus daily ka dose. So in daily ka funda I am giving you the concept, and in daily ka dose I am just discussing the question. To try to solve this question in daily ka dose, I am going to solve this question with what is the role of RB. So stay tuned with us, subscribe the channel so that you can join this and you can understand what is the concept here. So this is a homework for you guys. Try to solve this question. It is in GATE 2001 for electronics branch. Again, that is a relevant topic. Now, and in comments box, give me what is the role of RB. And guys, this is a shunt voltage regulator practice with previous year question, journey to gate, daily ka dose series. I am going to solve this question. Okay. Till then, join my Telegram channel, that is Electronics by Sanjay Rathi, and thank you for attending the session. Subscribe the channel, like the session, and share the link of this session. Thank you.